All right, good afternoon, everyone. Okay, so we will begin our tutorial since most of you guys are already in the class. Right, so as you know, it's a bit challenging juga sebenarnya nak buat tutorial online, especially for chapter 4, because chapter 4 is really the chapter where there's a lot of equation, there's a lot of information, of which I would very much prefer to be done physically, but we have to make do with what we have. So I will try my best, just that probably you have a little bit of confusion lah sebab in my tutorial, I will show you step by step. Sebenarnya saya dah type keluar dah segala step dia. Because I know if I expect you to do on your own sambil tengok tutorial ni, it's a bit challenging. So what you do for today tutorial, you just watch, okay? You just understand. Memanglah later on you have to go back and see the question. You have to digest back the information. Just that I would like to highlight apa benda yang kamu kena tahu dalam soalan. Important is that this tutorial online, you understand the question, what the question means, how it reflects in your calculation. Okay, then later on when you have time, then you will hopefully you will try to do the calculation by yourself. Okay, so I will not expect you to do it during this session sebab malam impossible jugalah untuk kamu buat. Tapi you just listen, you understand what the question means, how it's translated into calculation. Then later on you can do the calculation. Alright, before I forget, since we have no water this week, so lab pun tak adalah minggu ni, kita kena postpone kepada minggu depan. So a little bit stressful sebab towards the end of semester, you have a lot of assessment. So hopefully with the time given to you, you can complete first your mini project. Sebab tu saya dah bagi terus deadline mini project minggu 12 supaya kamu baik concentrate dulu on your mini project stage 2 so that later on bila kamu dah start buat lab, kamu dah kena busy dengan lab report, kamu dah kena busy dengan test and other assessment. So temporarily you have a little bit of time, I assume. You can do your stage 2. Stage 2 tu tak susah sebenarnya. If you really focus, you can actually finish half a day sahaja kamu dah boleh settle. Kalau kamu fokus lah, you have the time and focus, you can finish it on time. Right. Okay, so now I will go to tutorial question number chapter 4, right? So the questions are already on VLE. If you want to access to the question, you can download it. Okay, what I'm going to discuss is straight away the solution lah, right? Okay, but it's most important to understand what the question means. Okay, so we go to the first question. So the question says, the liquid phase reaction obeys the elementary rate law, carry out isothermally at 350 Kelvin in a flow system. Okay, so I told you before, chapter 4, the challenge is that you got a lot of equation. Although the equations are given, but you really have to know which equation for what situation. Sebab tu, to understand question is very important. So the first information, dia adalah liquid phase reaction dalam flow system. Okay, so kamu kena faham, kalau flow system, equation dia akan berbeza. It will be different depending on whether this is gas phase reaction atau liquid phase reaction. So you have to really know the difference dalam equation dia bila we are talking about gas phase atau liquid phase. Bila melibatkan flow system, maksudnya kalau melibatkan PFR, CSTR, they are flow reactors. You have to really know how the equation will be different according to the phase. Okay, next dia kata obeys elementary rate law. Okay, so kita come back kepada chapter 2 when we learn about rate law. So kamu tahu rate law ada elementary, non-elementary. Kalau non-elementary, the reaction order information will be given to you. Contohnya, katakan dia akan kata the reaction is first order with respect to A. Okay, so maksudnya minus RA equals to KCA or something like that. Meaning, kalau non-elementary, reaction order dia dah tak follow stoichiometric coefficient. So, the information has to be given to you. But on the other hand, this question says elementary rate law. Kalau elementary rate law, reaction order dia akan follow the stoichiometric coefficient. So meaning in this chemical reaction, I have 1A, 1B. I have two reactants. And the stoichiometric coefficient for A is 1 and for B is also 1, right? Because 1A, 1B. So the rate law will be first order with respect to A and first order with respect to B. So rate law dia akan menjadi minus RA equals to KCA CB. So first thing kamu kena tahu dulu to write down the correct rate law. Sebab kalau rate law kamu salah, kamu akan pilih equation yang salah. Kan saya pernah remind, equation tu bergantung kepada three things. Types of reactor, the phase, gas atau liquid, dan rate law dia. Rate law berbeza, equation yang digunakan akan berbeza. Okay, so kita dah establish rate law dia. Dan dia kata, carry out isothermally at 350 Kelvin. So when we talk about temperature, why is it important? Because the temperature will influence your K value. Sebab K value depends on your temperature. So dalam rate law tu, dalam equation tu, nilai K dia must be at our reaction temperature. So if our reaction temperature at 350 Kelvin, the K must be at 350 Kelvin. If you have K at any other temperature, you have to naturally understand, you have to find the K at your reaction temperature. Kamu tak boleh guna K pada suhu yang berlainan. Kena pada suhu tidak balas. Sebab nilai K will change with temperature. Okay, so establish dah. Dalam rate law saya, nilai K ni mesti pada 350 Kelvin. Right. Then dia kata, the initial concentration of A and B are 0.05 molar. So molar tu concentration, or we can put it as mole per liter. So they say, initial concentration of A, Ca0 0.05, Cb0 pun 0.05. Okay, so saya tahu saya ada dua reactant. Initial concentration A, Ca0 equals to Cb0 equals to 0.05. So why is this information important? First of all, kita tahu Ca0. Dan yang kedua, kalau kamu ingat saya pernah ajar kamu, if we know the initial amount of the reactants, when you have more than one, you can calculate theta B. Theta B ni akan sentiasa digunakan in equation ke, dalam stoichiometric table ke. Kalau kamu ada dua reactant, kamu tahu dia punya amount asal, regardless concentration ke, mole fraction ke, molar flow rate ke, you can calculate theta B. So what's theta B? If you forget, it's the ratio of initial amount of B over A. So it can be concentration, it can be molar flow rate, it can be molar fraction. But in this case, dia beri kita initial concentration, right? So we can calculate theta B. So Cb0 0.05, Ca0 pun 0.05. Therefore, you can get your theta B as 1. Okay, so when you do reaction question, sebelum kamu sampai kepada part yang last soalan tu pun, when you have information, kamu terus synthesize dalam bentuk number. You write down first rate law, you write down you calculate theta B. So even doing this, you already can get certain marks because means you understand the question and you can synthesize into calculation, into information dalam calculation. So you may not be able to solve the calculation, but you can synthesize information that also give you mark because it means you understand what the question wants. Alright, okay, so done. Okay, dia kata determine reaction, next one, at 100 liter per minute. So at this stage, dah minggu 9, kamu dah kena tahulah kalau liter per minute is volume per time. So this is volumetric flow rate. And kamu kena ingat volumetric flow rate, kamu dah kena tahu dia initial ke final. Sebab laju isi padu, okay, dia tak semestinya sama initial dengan final. Kalau dia adalah gas phase. Dalam kes ni liquid phase. So liquid phase kamu tak payah bimbang lah. The initial ke the final volumetric flow rate. Epsilon naught equals to epsilon equals to 100 liter per minute. So you can write down. Okay, like how I do in this calculation, I write down terus. Okay, Ca0 sama dengan Cb0 sama dengan 0.05. Epsilon naught 100 liter per minute. And then they say isothermally at 350 Kelvin. So I will write down, okay, temperature outlet equals to inlet initial temperature equals to 350 Kelvin. So you just write down first all the information. So why T equals to T0? Because this is isothermal, no change in temperature. So T equals to T0 equals to 350. Right, so that's so far. Then dia kata, determine that the reaction rate constant, K, is 0.7 at 300 Kelvin. So they do give us the value of K, but the K is at 300 Kelvin. So don't forget, the reaction temperature in our case is at 350. So therefore, K yang kita gunakan adalah mesti K at 350. Walaupun dia beri kita K, but the K they give us is at a different temperature. And this is activation energy, which is your EA. Okay, you should know by now, activation energy EA is 5 kilocalorie per mole. So that's all information that you have from the question. So you can see the one that I put in yellow, the first two lines is what we get from the question. And that we also calculated theta B. Sebab kita dah tahu C naught, kita tahu CV naught. Okay, so let us go to the question. It says a 500 liter continuous stir tank reactor. So I have a reactor, CSTR, volume dia 500 liter. So VCSTR 500 liter and 800 liter plug flow reactor. So VPFR 800. So I have VCSTR 500, VPFR 800 and dia kata available for the reaction. Okay, so sekarang ada dua reaktor, satu 500, satu 800, tapi dua reaktor yang berbeza. And dia kata which reactor is recommended for the reaction. So dia ask sekarang mana satu reaktor yang kita nak guna. Okay, so you imagine now the scenario is that I have this reaction, I want to conduct at this temperature, I have this situation, okay, and then dalam kita punya in our plan we already have these two choice of reactor, existing reactor. Either you want to use a 500 liter CSTR or a 800 liter PFR. So which reactor we recommend? Okay, so in this case, when we want to do recommendation, we will base our recommendation based on the conversion. Which reactor will give us a higher conversion? Okay, so in return means that in order for us to know that, we have to calculate the conversion. Kalau kita guna the 500 liter CSTR, dan apa dia conversion apabila kita menggunakan 800 liter PFR. So that's the calculation, cari conversion. Okay, so we start first dengan PFR. Okay, so like I said to you, the bonus part of chapter 4, the bonus part of this reaction engineering is that I provide you the equation. Tapi kalau kamu ingat equation dia banyak. So kamu kena betul-betul tahu which equation that you will use for which situation. Okay. So for this case, if you check the notes, right, the equation yang fulfill all three requirements, which is it must be a CSTR, it must be a liquid phase reaction of which the rate law is minus RA equals to KCACB. The equation that is going to be provided to you is in this red font. Okay, ini equation yang diberi kepada kamu di mana volume CSTR equals to FA naught multiply with X conversion in the CSTR over K 350 sebab tindak balas kita pada 350, CA naught power of 2 in bracket 1 minus X in bracket theta B minus B per AX. Okay, so again, if you wonder how this equation come, you check chapter 4, you kena betul-betul tahu equation mana. This equation represents the three characteristics that I told you previously. Okay. However, okay, kalau kamu perasan, saya juga ada explain kepada you that this equation can be translated into other form depending on the information provided to you. Okay, although you're given in this red font punya version, tapi equation ni boleh bertukar version depending on the information. Okay, why I said that? In order for me to use this equation, okay, kamu tahu kan kalau dalam penyelesaian mathematics, if I have one equation, okay, saya nak solvekan, saya kena hanya ada satu unknown. Satu equation, satu unknown, kita boleh solve. When you have one equation, you have more than one unknown, you takkan dapat, you can never solve that equation. So we call this degrees of freedom. Kalau ada dua unknown, mesti ada dua equation. Bilangan unknown dengan bilangan equation harus sama ataupun bilangan equation kena lebih daripada bilangan unknown baru kamu boleh solve. If you have more unknown than the number of equation, sampai bila pun kamu takkan dapat solve. Okay, so in our case, we have only one equation. We know what the unknown that we want to solve, which is the conversion X. Maksudnya unknown lain tu kamu dah kena tahu number dia. Kalau kamu tak tahu, kamu tak boleh solve. Right? Okay, so let us check. what unknowns kita dah tahu, what unknowns yang kita tak tahu lagi. Okay, so first of all, volume CSDR kita dah tahu lah kan, sebab in the question says this is a 500 liter CSDR. Okay, so belah kat kiri, the volume I dah solve. Okay, let us go to the right hand side. So right hand side, first of all, X ni yang kita nak cari. Okay, kita dah tahu F kita nak cari. So yang selebihnya kita dah kena tahu nilai dia lah. So first thing first, FA0. So kalau kamu perasan dalam question ni kita tak ada FA0. Okay, you have CA0, you have epsilon naught, but we don't have FA0. Okay, so some might say, which I also agree that, tapi kita boleh carikan FA0 sebab kita ada CA0, kita ada epsilon naught. Correct. Okay, so one way, okay, I show you different, I will discuss the different approach that student may use. Okay, so approach pertama, katakan kalau student tu nak guna equation merah ni, boleh, provided dia cari dulu FA0. Okay, dia boleh cari sebab kita ada CA0, kita ada epsilon naught. So kamu tahu kan kalau ada CA0, ada epsilon naught, you can find FA0. So one way. So means that you have to do extra calculation lah, cari FA0 dulu. Okay, so fine, that one also can. Okay, means we consider FA0, kita boleh cari. So we go down pula. Okay, down, next is K. So K at 350. So you know, our challenge is that although we have K, but the K is at 300 Kelvin. So you know, naturally, we have to find lah K pada suhu 350. So you have learned this kan dalam Arrhenius equation. Equation dia beritahu K2 equals to K1 exponential EA per R in bracket 1 per T1 minus 1 per T2. Maksudnya kalau saya ada K1, T1, maknanya saya ada K pada 300 Kelvin, saya tahu T1 300 Kelvin, saya tahu T2 saya 350 Kelvin, saya boleh cari K at 350. So this is nothing new for you. You already done this before. Equation is also provided. Okay, you must understand nilai EA macam mana kita nak gunakan. So EA is given to you as 5 kilocalorie per mole. Dalam soalan lebih tahu dah EA 5 kilocalorie per mole. But because our R value is always in calorie or joule, okay, you convert your kilocalorie kepada calorie dengan times 1000. Okay, you divide by the R value. When you know your EA is in calorie, your R value is 1.987 calorie per mole Kelvin. So you replace into the equation, you will get the value of K at 350 Kelvin as 2.32. So as always I mentioned previously dalam class tutorial, as long K value will increase with temperature. So kalau K pada 300 Kelvin is 0.7, you can see at 350 nilai K dia 2.32. So when you calculate the value of K and you see that the K increase with temperature, most likely your answer is correct. Okay, so done, dah dapat nilai K. So CA0 kita dah tahu kan, CA0 dah diberi 0.05 from question. So I can replace CA0. So 1 minus X ni, kan X tu kita nak cari, kita biarkan. Kurungan dalam kurungan tu kita biarkan. The next bracket, theta B, which we have find previously because we know the initial concentration of B equals to initial concentration of A. I can calculate my theta B as 1 from the calculation. So theta B is 1 and then minus B per A. So B per A tu adalah stoichiometric coefficient ratio. So you can see from the equation 1A react with 1B. So B per A dia adalah 1 over 1. Okay, multiply dengan X. Okay, so sekarang kita boleh nampak from the rate on calculation, kamu dah boleh solve. Sebab saya dah ada segala nombor kecuali X, saya dah boleh solve. Tapi bear in mind, that's why hopefully later you can practice by yourself. Sebab ini adalah persamaan quadratic. Okay, when you solve it, you will get a quadratic equation. So make sure when you have the time, you have to really practice. Okay, you have to really practice whether kamu dah tahu tak, dah biasakan diri tak untuk solve quadratic equation. Right, okay. Next, kalau kamu tempat penyelesaian saya sekarang, saya tak guna yang version merah tu. Instead saya guna version hitam ni. Tapi version hitam ni sebenarnya comes from this red version juga. Okay, dalam version merah yang diberi in test or exam, you're given this red version. Okay, sekarang kami nampak yang kalau saya ada satu FA0 di atas and I have one CA0 di bawah, okay, so FA0 divided by 1 CA0 at the bottom is equal to epsilon naught. So sekarang apa saya buat? Saya cari version kedua di mana saya terus guna epsilon naught. Kalau version merah, kamu kena cari FA0 dulu. Maknanya kamu buat kerja berganda lah. Kamu cari FA0 through CA0 epsilon naught. Kamu ganti dalam, kamu kira 2 kali. Kalau kamu guna version yang kedua, kamu terus ganti dah satu FA0 dengan satu CA0 di bawah dengan epsilon naught. Sebab FA0 per CA0 equals to epsilon naught. So I get the black version of the equation. The one provided to you is the red color one. But if you want to have easier calculation, if you know how to convert by yourself, you will get the second version. So the second version is easier for you to use. Sebab kamu directly terus substitute epsilon naught with 100 liter per minute, which is what I do in my solution here. Benda lain masih sama. Okay, yang macam kita discuss, the K is still the same. We have to find the new K. The rest are still the same. Just like the second version, you straight away ganti dengan epsilon naught. Just that provided, you must understand the equation yang saya highlight ni tak diberi, yang diberi dalam font yang merah ni. Ni equation diberi. Okay. Okay, in the end, you will get, when you do the solution, the quadratic equation, you can see here, the entire equation, all are numbers except for your conversion. Therefore, you can get the conversion of the CSTR as 0.29, which is 29%. Okay, so I go to the next one, PFR. Okay, so PFR, again, sama concept. You have to go and look at your chapter 4, the notes, equation yang memenuhi the 3 characteristics. PFR, liquid phase with the rate law minus RA equals to KCACB. Okay, you have to look at these 3. Only you will then get the one equation that fulfills these characteristics. Okay, so the equation says the volume of the PFR equals to FA0 per K350 CA0 square in bracket XPFR per 1 minus XPFR. Dia benda yang sama. Tadi kita cari conversion CSTR. Sekarang kita nak compare dengan conversion bila kita guna PFR. So sebenarnya dia tak susah bila kamu dah tahu equation. Bila kamu dah kenal pasti identify the correct equation. It's only a challenge if you do not identify the correct equation. So kalau kamu ganti equation yang salah, then you may, the entire equation itu salah lah kalau kamu pilih equation yang salah. Okay, so subsequently you do the same. Okay, font merah ni adalah yang diberi dalam note, dalam exam, dalam test. The red one is given to you. So if you want to use the red version pun boleh, sebab again, kamu kena cari FA0 dulu. Kalau kamu guna yang version merah ni, dia menggunakan FA0. Soalan kita tak ada FA0, tapi soalan kita ada CA0 epsilon naught. You can find FA0. Kita dah belajar kan? So CA0 sama dengan FA0 per epsilon naught. Maka kalau kamu nak cari FA0 equals to CA0 multiply with epsilon naught, you get FA0. You substitute inside. Or if you want a faster way, saya guna version yang hitam ni. Version hitam ni apa beza dia? Sama konsep. When I have one FA0 at the top, I have one CA0 at the bottom, I can divide them and I get epsilon naught directly. So epsilon naught, okay, maknanya bawah akan tinggal K at 350 and CA0. Satu CA0 tinggal sebab saya boleh cancel one CA0. The bracket at the back is still the same. So I do the same thing, I substitute with numbers. So just that, except that the volume untuk PFR in the question was 800 liter. So you replace lah 800 liter. Okay, the rest information you replace subsequently and you will get the conversion of the PFR as 0.48. So solution PFR ni senang sikit, dia bukan quadratic. Yang CSTR ni is quadratic. So you better have, if you have time, you have to practice sebab dalam test dengan exam akan keluar di mana penyelesaiannya kamu kena solve quadratic equation. Okay, nevertheless, don't forget, after you calculated, you must answer the question. Sebab dia kata question tu tanya, apa reactor yang kamu akan recommend? So, based on the comparison of the conversion, we can say that the 800 liter PFR give us a higher conversion. So, therefore, we recommend using the PFR, the 800 liter PFR, as they produce or they give us a higher conversion. So, that's all for question A. Okay, so we go to the next question, right? The next question, okay, this is a bit hard. Okay, to increase the conversion from the first CSTR in part A above, the technologists decided to add another equal volume CSTR to the first CSTR in the series. Therefore, determine the overall conversion from the second CSTR. Okay, so soalan ni macam pelik sikit kan? Okay, soalan ni kata, part A kan kita dah kira kan conversion daripada CSTR, conversion daripada PFR. Okay, so kita reaktor yang the PFR yang CSTR yang kita ada dalam part A ni, dia adalah CSTR yang 500 liter CSTR. So, satu reaktor CSTR tu dia hanya beri conversion 0.29. Okay, sebab conversion daripada first CSTR ni rendah, dia tambah lagi satu CSTR dalam sistem of equal volume. Maknanya reaktor kedua saya pun adalah 500 liter CSTR. So saya sambung first CSTR 500 liter yang mencapai 0.29. I connect in series to the next CSTR of a 500 liter or so, and I would like to know what is the conversion pada reaktor yang kedua bersiri tu. Apabila saya tambahkan reaktor kedua itu. Okay, so maksudnya kita kena cari X2 lah. Kita dah tahu X. Kita tahu volume CSTR1 500 liter, X1 0.29. I have volume CSTR2 500 liter, X2 tu kita nak cari. Okay, so if you realize in my notes for chapter 4, I do not provide the calculation to calculate for reactor berseries. However, we did learn a little bit reactor in series dalam chapter 2. Kalau kamu ingat dalam chapter 2, kamu dah belajar nak cari volume reactor bersiri, tetapi you are given the information in the form of table atau Levenspiel plot. Means kamu just ganti daripada Levenspiel plot punya nilai ataupun daripada table punya nilai untuk kamu cari volume CSTR yang bersiri. Punya reaktor pertama, reaktor kedua. Okay, so we have to learn how to change equation tu sekarang. Sebab dalam chapter 2, nilai minus RA tu kamu dah tahu. Dalam chapter 4, nilai minus RA tu kita tak tahu. Kita kena tahu macam mana nak cari. Okay, so this is something different. Notes tak ada. So you have to a little bit understand how we do this. Okay, now first thing first. How do we do this? Okay, kamu kena ingat. Kita ada rate law kan? Kita ada rate law dalam reaktor pertama. Reaktor kedua pun kita ada rate law dia. So apa beza dia? Tadi we learn in the first reactor, rate law dia minus RA equals to K 350 CA CB. Maknanya first order with respect to A, first order with respect to B. Itu bentuk reaktor pertama. Okay, so katakan kita namakan dia minus RA1. Now, for reaktor kedua, kita tak boleh guna minus RA1. Kita dah kena guna minus RA2. Means the rate law in the second reactor. So, apa beza dia? Okay. K at 350 masih sama sebab as long as saya tak tukar suhu, reaktor pertama ke, reaktor kedua ke, reaktor ketiga ke, suhu sama, nilai K masih sama. Which is at 350 Kelvin. So, K pada 350 Kelvin ni, kita dah kira tadi kan. We already calculated previously 2.32. So, nilai K tu kita masih boleh guna. What about CACB? So, now that I have the second reactor, so the CA and CB must be in the second reactor. So, maksudnya CA2, CB2. Okay, kalau reaktor pertama, CA1, CAB1. Kalau sekarang reaktor kedua, it must be the concentration of A in the second reactor, CA2. Concentration of B in the second reactor, CB2. So, kenapa concentration dia dah berlainan? Sebab ingat, conversion tak sama kan? Conversion reaktor pertama 0.29. Conversion reaktor kedua, kita tak tahu lagi. Okay, tapi kita tahu dia takkan sama 0.29 sebab conversion akan meningkat dengan bilangan reaktor. Okay, so that's the problem. CA2 ada CB2. Right, okay now. come back to the design equation. So sekarang kamu kena belajar nak develop balik design equation kalau saya nak kira untuk reaktor kedua CSTR. So for liquid phase flow reactor CSTR kedua, if you remember in chapter 2, we know the equation is volume CSTR2 equals to FA0 in bracket X2 minus X1. Ingat tak kalau reaktor pertama FA0 X1. Kalau reaktor kedua, FA0 dalam bracket X2 minus X1. Close bracket per minus RA2. Rate law dalam reaktor kedua. Okay, so then minus RA2 kita dah tahu. Tadi saya dah terangkan minus RA2 equals to K350 CA2 CB2. Okay, so kita dah sampai sini. Kita dah tahu. Okay, now you have learned juga dalam chapter 3. Kita kan nak cari conversion kan, kita nak kena tahu apa tu CA2, apa tu CB2. Okay, so you have learned in chapter 3, CA sama dengan CA0 dalam bracket 1 minus X. Tapi sekarang ni adalah CA2, concentration untuk A pada reaktor yang kedua. Kalau reaktor pertama ataupun concentration yang biasa, single reactor, CA sama dengan CA0 in bracket 1 minus X. Kalau dia adalah CA2, apa beza dia? CA0 masih ada. Dalam bracket now become 1 minus X2. Sebab concentration A in the second reactor will be based on the conversion in the second reactor, which is X2. So similarly untuk case CB. So CB2 is equals to CA0 in bracket theta B minus B per A X. Sorry. So kalau CB akan menjadi equals to CA0 in bracket theta B minus B per A X. Kalau dia adalah CB2, so akan menjadi equals to CA0 dalam bracket theta B minus B per A X2. So sekarang sebab dia mesti berdasarkan conversion dalam second reactor. So if you may get confused, kenapa CA0 ni tak berbeza? Sebab kamu kena ingat, CA0 ni berdasarkan the initial concentration yang mula-mula masuk pada reaktor pertama. Kamu sambung banyak-banyak reaktor pun, the initial concentration yang kamu prepare pada waktu asal yang kamu masuk pada reaktor pertama masih CA0 yang sama. So regardless kamu tu banyak reaktor pun, the CA0 will be the same. But the conversion will be different. Sebab kalau reaktor pertama, conversion dia berlainan. Reaktor kedua, conversion dia berlainan. So reaktor pertama X1, X2, X1. Reaktor kedua X2. Reaktor ketiga X3, so on and so forth. So now that saya dah find CA2 and CB2 in the form of CA0 and X2, saya combinekan. So saya combinekan yang kuning ni CA2, CB2 with the original equation, this one. So it become volume CSTR kedua sama dengan FA0 in bracket X2 minus X1 per K350. Tadi kita dah express CA2 sama dengan CA0 1 minus X2, CB2 equals to CA0 in bracket theta B minus B per A X2. So now I already express myself the equation how to find the volume of your second CSTR. Tetapi remember in our question this one kita nak cari baru perasan. Yes, Umi Natila, you will ask something? You can. Hi Umi. Yes, boleh. Ya.
Formula CB kan dia ada B per A kan? Should be B per
CB yang ni ke?
Yes.
Betul. Okay. B per A.
Should be kan value dia 1 kan?
Betul.
Kalau tak letak B per A tu boleh ke?
Kamu kena ingat dia tak semestinya 1. Dalam equation ni B per A tu 1 sebab so happen reaction dia 1A 1B. So you have to familiarize yourself yang equation tu ada B per A sebab tak semestinya dalam semua situation 1A akan bertindak balas dengan 1B. There may be time where mungkin 1A tindak balas dengan 2B, 2A dengan 1B. Faham tak? Right, okay. So good to ask that. So anybody kalau ada soalan, you can always just interact. Kamu just raise hand kalau kamu nak tanya masa buat tutorial. Okay, thank you Umi for the question. Good question. Right. Okay, so now that I already have this, I combine, I get into this form. Okay, similar explanation. Kamu nak guna dalam bentuk FA0, FA0 dalam bentuk yang pertama yang melibatkan FA0 pun boleh. Tetapi means kamu kena cari dulu FA0 itu. Okay, macam saya kata, kamu kena cari FA0 first because again, like same in question 1, question part A, saya ada CA0, saya ada epsilon 0. So I can use that to find first FA0 and you can use the first form. Or if for me, saya nak potong sikit kerja, saya tahu ada satu FA0 di atas, ada satu CA0 di bawah. I can divide them and I will get epsilon 0. Okay, so saya terus guna nombor dia. Saya dah tak payah macam kamu kira berganda lah. And basically kamu mengcancelkan sama sendiri je. So tak salah, but a little bit longer way. So I use a little bit shorter way. I straight away bahagikan, I dapat satu epsilon 0 di atas dan sekarang di bawah akan tinggal satu CA0 sebab saya hanya boleh cancel one CA0. So I will substitute into this equation. So again, bila kamu nak solve mathematical equation, kamu dah tahu apa yang kamu nak, what you want is X2. The rest you have to find the numbers first. Okay, so the volume CSTR2 I already know is 500 liters, but dia kata my second reactor is equal volume to the first reactor, which is 500 liter. So left hand side dah settled. Right hand side epsilon 0, 100 liter per minute from the question. X2 I want to find. X1 is the one conversion we calculated in part A in the first reactor, which is 0.29. K, the one that we calculated previously at 350 Kelvin, which is 2.32. CA0 question given 0.05. And then belakang ni, you have to solve lah. Okay, again, you will see that this is a quadratic equation. Okay, so we want to find X. So if you calculate correctly, you will get your second reactor conversion for your CSTR is 0.46. Meaning kalau tadi reaktor pertama, we achieve 29% conversion. When we connect to another one more 500 liter CSTR, the conversion increase subsequently to 46%. So let's say kamu calculate, kamu dapat X2 tu lebih rendah, confirm lah kamu check balik sebab it's impossible conversion tu akan berkurangan, conversion tu akan bertambah when you add on the next reactor. Okay, so that's for question number 2. So I think I go quite slow so that you can really understand the question. Okay, now next. Third question. So third C. So C soalan dia, determine the reaction time when the reaction is conducted in a batch reactor to achieve conversion of 48%. Okay, sekarang kita tukar completely reaktor yang baru. Tadi kita guna PFR, CSTR. Sekarang kita guna batch reactor. So batch reactor. So syarat dia sekarang batch reactor, liquid phase with the rate law masih minus RA equals to KCACB. So kamu kena faham. Okay, walaupun kamu tukar reaktor pun, rate law dia masih sama. Nilai K dia pun masih sama. Okay, so nanti dalam mini project, you don't get confused. Kadang-kadang bila kamu tengok pada literature, dia mungkin tak menggunakan reaktor yang you are being assigned. But as long as the reaction is still the same reaction, the rate law is still the same, the value of K is still the same, the value of EA also still the same. Just like kamu assume I'm now designing a different reactor for the very same reaction. So macam case ni, kamu kena assume macam tu. Sekarang, instead of using PFR CSTR, I use it in a batch reactor. Tapi dalam batch reactor, we don't talk about volume. Batch reactor, we talk about reaction time. Kita nak tahu kalau saya run dalam in my batch reactor, how long it takes for the reaction. So you go back, you check the notes, chapter 4. If it's a batch liquid phase, rate law minus RA equals to KCACB. There's only one equation that fulfill this, which is in the red font as I showed here. So the equation says the reaction time equals to 1 per K 350 CA0 in bracket X per 1 minus X. Terus ada equation dia. Okay, tapi itulah macam saya tutorial ni saya terus tunjuk equation tu. Tapi dalam exam, dalam test, I will give you all the equation. So kamu kena betul-betul ingat pula kalau rate law ni equation mana, rate law ni equation yang mana. Okay, so subsequently I just replace all with numbers sebab saya dah tahu conversion. saya dah tahu nilai K, saya tahu nilai CA0. So this one straightforward lah. I can find the reaction time. I will get 7.96 minutes. Means for this reaction, to achieve 48% conversion, it takes only 7.96 minutes. So this is quite an easy question lah for you. Okay, so we go to the next one. Right, so now soalan ni a little bit change. Okay, the same batch reactor used in part C was cooled to 280 Kelvin. Okay, sekarang dia kata reaktor kita guna dalam part C tu sekarang, kita guna reaktor yang sama tapi kita guna pada suhu yang lebih rendah, which is at 280 Kelvin. Tadi pada C ni, kita guna pada suhu tindak balas kita, which is 350. So, maksud sekarang saya dah guna pula suhu yang berlainan, 280. Okay, calculate the new reaction time. So kita kira reaction time yang baru and subsequently discuss the effect of cooling down towards reaction time if the same conversion were achieved here. So this question is a bit unique. Saya nak guna reaktor yang sama, but I reduce the temperature from 350 to 280 Kelvin and they ask us to find the new time. And lepas tu kita kena discuss, ada tak apa kesannya terhadap the reaction time if I cool down my reactor or I use my reactor at a lower reaction time. Okay, so that's how now kamu kena faham. What will affect my reaction time? Okay, so kamu kena now come back. Kamu tengok kat equation dia sebab you will still use the same equation, okay, to find the reaction time. But now you have to figure out what will change if I change temperature? Sebab dia kata conversion masih sama. So you can see from this equation, conversion is still the same. CA0 is still the same. They didn't say they changed the initial concentration. So you have to understand the fundamentals lah. If I change temperature, the one that will change is the value of K because K value follows the reaction temperature. So if I change from 350 to 280, I have to actually find the new K. Okay, so now this part you may get a bit confused sebab sekarang kamu ada dua kombinasi K yang berbeza kan sebab daripada soalan dia beri kamu K at 300 as 0.7. You also calculated the new K at 350 which is 2.32. Sekarang suruh kira pula K pada 280. So you may ask, kita nak guna set yang mana? 300 0.7 or 350 2.32. The answer is you use any set pun sama sahaja nilai dia. Dia takkan berbeza. Provided you use the correct EA and you use the correct temperature combination. If you want to use 0.7, it must be with 300 Kelvin. If you want to use 2.32, it must be with 350 Kelvin. Either one you use to find the K at 280 will be the same. Sebab, kamu kena faham pula, bila suhu berubah, yang berubah adalah nilai K. Nilai A, nilai EA tak berubah. Okay, hanya nilai K saja. Sebab tu kamu guna any combination. Kalau kamu buat, if you calculate correctly, you will still get the same value of the K at 280, which is 0.38. So you can see that's the only thing that different. So you calculate back the reaction time by substituting the new K at 280, you will get the reaction time as 48.58 minutes. So you can see here, tadi at 350, the time needed for me for the same reaction, conversion 48% was only 7.96 minit. Tapi bila saya tukar kepada 280, masa dia menjadi 48 minit. So what's the answer? Meaning the reaction time will increase when you cool down the reaction temperature. Okay, sebab tu kadang-kadang I always tell you kenapa kita akan certain reaction kita akan guna pada suhu yang tinggi. Sebab bila guna suhu yang tinggi, nilai K akan meningkat dan ini yang menyebabkan your time for the reaction will decrease. That's why the effect of temperature is very important in your reaction, which is also reflected in this example of calculation. Okay, so we are done for question number 1. Okay, so I can understand memang you will not have the time to do it. Okay, it's okay. You just understand first, okay, my explanation, and then later on when you have time, you try to calculate by yourself. And in fact, in this video, you have seen all the detailed calculation. Should not be a problem for you, okay, to try to do it by yourself. Okay, So we go to the next question, question number 2. So the question now becomes significantly harder and harder dah sebenarnya. Okay, so question number 2. The liquid phase reaction follows elementary rate law. So again, first information dia adalah liquid phase. Okay, second information, okay, dia adalah follow elementary rate law. Okay, so kalau follow elementary rate law, teruslah kamu tengok reaction order dia terus ikut stoichiometric coefficient. So in this question, I have 1A, 1B. So the rate law will be first order with respect to A and first order with respect to B. So rate law dia minus RA equals to KCA CB. So done. Kita dah tahu rate law dia. Okay. So next one. This is the initial concentration of reactant A is 3 mole per dm cube. So Ca naught 3 per mole dm cube. So saya terus tulis 3 per mole dm cube Ca naught. And dia kata the molar feed rate of reactant B is 5 times that of A. So kamu tahu kan molar feed rate tu molar flow rate lah kan. Okay, and molar feed rate means initial molar flow rate. Dia kata initial molar flow rate of B, FB naught adalah 5 kali ganda molar flow rate A, FA naught. So means kalau kita nak express dalam bentuk pengiraan, FB naught equals to 5 FA naught. So dia kata molar feed rate B is 5 times that of A. Molar flow rate B bersamaan dengan 5 kali ganda molar flow rate A. So FB naught sama dengan 5 FA naught. So you may ask, apa pentingnya information ni? Kan kamu ingat, kalau kita tahu initial amount, regardless molar flow rate ke, concentration ke, mole fraction ke, when we know the perkaitan or the relationship, we can use it to find theta B. So that's the important thing. Dapat satu sentence ni, it actually tells you, you can use that sentence to find the correlation between FA naught dan FB naught, and subsequently you can use it to find theta B, which is now 5. Dalam soalan ni, theta B is 5 because of the sentence that says molar feed rate of reactant B is 5 times that of A. So done, I got my theta B. Okay, next information. The reaction rate constant of the reaction is 2. So your K is 2. Okay, so dalam soalan ni, dia tak cakap nilai K ni pada suhu apa. But they says of the reaction. So you may assume, safely assume, this value of K is at reaction temperature. Okay, bila dia terus beritahu nilai K, dia tak cakap pada suhu apa, you can safely assume dia adalah nilai K pada suhu tindak balas saya. Maksudnya, saya tak payah cari nilai K yang baru, saya terus guna nilai K yang diberi. Okay. So they give us the molecular weight of C as 60 gram per mole. So kita tahulah kenapa dia bagi, tapi dia beri kita molecular weight. So molecular weight C adalah 60 gram per mole. So later on we'll find out kenapa dia beri kita molecular weight. Okay, so the question says, A, determine the conversion. So again dia nak X. If you were to produce 5 million gram per year of product C. Okay, so dia kata dia nak cari conversion dalam reaktor kita. Kalau setiap tahun saya kena hasilkan 5 million gram produk C. So kamu bayangkan plant saya beroperasi sepanjang tahun tu. Okay, saya nak tahu kalau saya nak hasilkan at the end of the year saya nak hasilkan 5 million gram for that product C. What is the volume in my reactor? Then reactor saya pula dah ada volume dia. Volume dia adalah 5 dm cube isothermal CSTR. Maksudnya katakan sekarang kamu buka plant kamu ada satu reaktor, satu CSTR, 5 dm cube. Kamu nak tahu berapa conversion yang saya mesti capai dalam reaktor saya kalau at the end of the year I must produce 5 million gram of that product C. Dan juga ada limitation of my plant. Plant saya tak beroperasi 365 day, 24 hours per day, 7 days per week. Tak juga. Plant saya ada limitation dia. The plant only operates 12 hours per day. Every month hanya 25 hari dan untuk setiap tahun hanya 11 bulan. So kamu kena ambil kira juga. Okay. Berapa conversion reaktor saya? Kalau reaktor saya 5 dm cube dan reaktor saya hanya beroperasi pada jangka masa yang ini sahaja. Tapi saya mesti produce 5 million gram per year of that product C. Okay, so that is the challenge of the question, right? Okay, so sekarang first thing first. Okay, what is this 5 million gram per year? So kalau kamu tahu konsep, kita tukar dalam bentuk dimension dulu. Okay, gram tu mass, year tu time. Mass per time, mass flow rate. Kan sama kan kalau mole per time, molar flow rate. Volume per time, volumetric flow rate. So I have mass per time, molar mass flow rate. So mass flow rate untuk apa? Mass flow rate untuk produk C. So normally mass flow rate kita guna M. So MC, M subscript C means mass flow rate of C as 5 million gram per year. Okay, so that's all information yang kita ada. Now kita tengok, kita kena tahu, of course kalau nak cari conversion, kita tahu volume, kita mestilah guna equation dia kan, design equation dia. Okay, so you have to go back, check dalam list, apa equation yang memenuhi that 3 criteria again. CSTR, liquid phase, rate law minus RA equals to KCACB. Kamu kena make sure equation yang kamu pilih tu fulfill all these 3. Even if satu tak fulfill pun equation tu dah tak valid. Okay, so if you check correctly, the only one equation that fulfill this is this equation, di mana volume CSTR equals to FA0 X per K CA0 in bracket 1 minus X CA0 in bracket theta B minus B per AX. Okay, so essentially we will use this equation to find X. Kan dia tahu kita punya X. Okay, so maksudnya the other unknowns kamu kena solve dulu. Kalau kamu tak solve, you can never find your X. So we go one by one. Okay, first of all, volume CSTR kita dah tahu, right? It's given as 5 dm cube. Okay, so belakang kiri, the volume kita dah tahu. Okay, solve. Okay, kita tengok belakang kanan pula. Apa benda lagi yang kita tak dapat solve? Okay, first thing first, kita tahu FA0. So sekarang masalah dia sekarang sebenarnya we do not have FA0. Okay, kalau kamu tengok persoalan, FA0 tu adalah initial molar flow rate kan. Kita tak ada FA0. Kita ada adalah CA0. Kita ada K. Kita ada volume. Kita tak ada FA0, which is molar flow rate of, initial molar flow rate of A. However, okay, some may ask, kan tadi kita kan dah cari dah perkaitan FB0 sama dengan 5 kali ganda FA0. Itu adalah perkaitan untuk mencari theta B. FA0 tu still kita tak tahu nombornya. We need to know the numbers. Okay, so how do we do this? So if you remember, sebab tu kadang-kadang cabaran chapter 4, kamu kena correlate dengan chapter-chapter yang berlainan. Dalam chapter 3, based on stoichiometric table, that's why you learn the stoichiometric table. Bukan saja untuk isi table tu, tetapi kalau kamu ingat, from stoichiometric table, there is a correlation between FC dengan FA0. Kalau kamu ingat, FC tu adalah molar flow rate C lah. Okay, from the stoichiometric table, it gives us the correlation between FC dengan FA0, of which FC equals to C per A FA0 X. Okay, so that's the challenge in reaction engineering question. Dia chapter tu tak boleh in silo. Maksudnya kalau kamu belajar chapter 4, kamu tak tengok chapter 3, you cannot solve sebab you will and must need information from other chapter untuk solve soalan ni. So, contoh ni, chapter 3 tells you that FC sama dengan C per A FA0 X. Maksudnya, kalau saya tahu FC, saya boleh dapat FA0. But you may ask, tapi FC pun kita tak tahu, which is correct. I do not know the molar flow rate of C, outlet molar flow rate of C. But if you remember, I have mass flow rate of C. 5 million gram per year itu adalah mass flow rate. So saya ada mass flow rate of C, MC. Tapi saya nak FC sebab kalau ada FC baru boleh cari FA0, right? But you know, kalau mass flow rate nak tukar kepada molar flow rate, dia sama kan macam mass to mole. Mass per time tukar kepada mole per time pun sama konsep dia. You can convert using molecular weight. So molecular weight is actually a conversion factor. Sebab molecular weight of C adalah 60 gram per mole. So kamu ingat kan, dia adalah conversion factor yang mana you can use molecular weight to change from mass to mole or the other way around. Okay, in our case, you want to change from mass flow rate to molar flow rate. Kita nak tukar daripada MC kepada FC. Okay, so then it comes the question. Nak tukar kepada FC ni memang boleh tukar lah. But apa unit FC? Sebab FC ni molar flow rate kan, mole per time. Okay lah, unit mole tu kita dah tahulah, kita nak mole. Tapi time, kita ada time unit banyak kan? Hour, second, minute. How do we know what unit time yang kita nak convert? Sebab kita ada yang initially adalah kg per, gram per year. Saya nak tukar kepada mole per, kepada apa? Mole per year ke? Mole per hour ke? Mole per minute ke? Mole per second? So, to answer this question, I will just look at information yang lain dalam soalan saya. Okay, ada tak information lain yang melibatkan unit masa? So, you can see from the question, there's only one information yang melibatkan unit masa, which is our value K. Sebab value K dia beri 2 dm cube per mole hour. Maksudnya, saya kena tukarlah unit time saya kepada hour. So means my aim is to change from gram per year, MC gram per year kepada mole per hour. So kamu pelajaran CPP kan, kamu kena tahu permulaan apa yang kamu, unit yang kamu ada dan perakhirannya unit apa yang kamu nak. So saya nak tukar daripada gram per year kepada mole per hour. Means saya kena convert gram kepada mole dan year kepada hour. Okay, so I have to do one by one. Right, so to find FC, molar flow rate of C, okay, kamu tahu kita start dengan mass flow rate kita, which is 5 million gram per year. So kalau saya nak tukar daripada gram kepada mole, saya kena divide with the molecular weight. Maksudnya molecular weight saya kena bagi dengan molecular weight. So macam mana kamu nak tahu betul atau tidak? Okay, kamu tahu kamu boleh buat pembatalan unit. Okay, so if you divide by molecular weight, maka akan menjadi darab dengan 1 per 60, maknanya 60 gram di bawah, mol di atas kan, sebab kita bahagi kan. Okay, so kalau gram di bawah, nombor 60 tu akan ikut gram. So 60 gram di bawah, mol di atas. So katakan, I want to know whether correct or not. You can do unit cancellation. I can cancel the gram from the million, for the 5 million. I can cancel with the gram from the molecular weight. So katakanlah kamu tak pasti bahagi atau darab. Katakan kamu darab 60 gram per mole. Gram tu takkan terbatal. Sebab 2 gram berada di atas, kamu takkan dapat batal. So definitely not right lah. The only way for you to cancel the gram is by dividing with 60 gram per mole. So when you do this, kamu tengok sekarang unit kamu adalah mole per year. Still tak boleh solve sebab kita nak mole per hour. Okay, so now saya nak convert year kepada hour. To convert year kepada hour, kamu tak boleh guna konsep 1 tahun 365 hari, 1 hari 24 jam, so on and so forth. Sebab plan saya ni 1 year tu ada limitation operational time saya. In my 1 year that I want to calculate, I want to convert from year kepada hour, I must consider the operating capacities of my plant, which they have already mentioned. Sebab dia kata untuk setiap 1 tahun, I only operate 11 month. So saya tukar. Saya darab 1 year per 11 bulan. Okay, kenapa saya buat 1 year divide by 11 months? Sebab kalau kamu tengok, originally ada 1 year, ada year daripada unit saya pembawah. So saya kena darab kena darab year, kena bahagi 11 month per year. Baru saya boleh cancel year and year. Saya sekarang tinggal mole per month. Okay, so again, kalau kamu confused, kenapa kena bahagi 11 month per year? Kenapa tak boleh buat darab 11 month per year? Kalau kamu darab 11 month per year, unit year takkan terbatal, takkan solve lah problem dia. Okay, now my unit is still mole per month. Belum solve lagi sebab saya nak dalam mole per hour. Dan dia kata untuk setiap 1 bulan, I only operate 25 days. So again, saya cancel month, saya bahagi dengan 25 days. Now I'm left with mole per day. Then they say for every 1 day, I only work 12 hours. So sekarang saya bahagi pula dengan 12 hours. So unit day terbatal, sekarang saya tinggal dengan hour. So when I calculate this, I divide correctly, I will get my FC, molar flow rate of C as 25.25 mole per hour. So you can see this is a challenge di mana dalam note saya, dalam lecture saya tak discuss. So now I do in tutorial, I will discuss the different way of how the information can be communicated to you for you to calculate. Okay, so now saya dah tahu kalau saya nak hasilkan 5 million gram per year of product C, molar flow rate yang saya kena ada dalam reaktor saya, mass flow rate of C dalam reaktor saya adalah 25.25 mole per hour. Setiap 1 hour saya kena hasilkan 25.25 mole of C. Okay, then maybe you must back. Kenapa kita cari FC kan? Jangan lupa we have to find FC in order for us to find FA0 sebab dalam soalan kita ada FA0. So from the stoichiometric table, the correlation is FC equals to C per A FA0 X. C per A ni adalah stoichiometric coefficient. So your C per A, if you look from the table, C per A kamu adalah 2/1. Okay, so kamu tengok sini apa yang saya buat. FC equals to 25.25 from the calculation here equals to 2FA0X sebab C per A saya adalah 2. Okay, 2/1 actually. So it becomes 2 lah kan. Okay, so then don't forget saya nak cari apa? FA0. So saya kena solve, maka saya dapat correlation saya FA0 equals to 25.25 divide by 2x daripada correlation ni. I hope you can see from this correlation, saya bawa 2 dengan x daripada belah kiri ke belah kanan. So saya dapat 25 bahagi dengan 2x, maka equals to 12.63x. So FA0 saya bersamaan dengan 12.63 over x. Mana FC tu? Tadi kan FC kita dah kira 25.25. So kita ganti dalam. Kita dapat FA0 tu tapi dalam bentuk number dan X. Tak apa. X tu tak apa sebab ingat tak? You can introduce X. Kamu boleh introduce variables baru dalam equation kamu. Tapi variables tu mesti variables yang kamu nak cari. Dalam kes ni memanglah dia masih dalam bentuk X. Tapi tak apa sebab saya kan nak cari X. So not a problem. I just basically add another X to the equation. Tapi it's okay because I want to find the X. Okay, so done. FA0 tu kita dah tahu. Okay, then we go down. K we already given as 2. CA0 is given as 3. Kita dah tahu CA0. Okay, X kita nak cari lah kan. Theta B tadi kita dah discuss is 5 from the sentence. B per A is 1. Okay, sebab satu A, satu B. So again, I will always write B per A sebab dia tak semestinya 1. Okay, kamu kena remember, you cannot assume it's 1. The equation say is B per A. Dia hanya akan jadi 1 kalau betul equation tu adalah 1A reacting with 1B. Okay, so I replace into the equation. So kamu tengok part ni, it's very interesting, you see. FA0 tadi kita dah terbitkan, we have already formed, we already find as equals to 12.63 per X. So 12.63 per X, kalau kamu tengok, kita akan darab dengan satu X lagi sebab dia kan FA0X. So basically, terbatal lah X itu pada kat bahagian atas sebenarnya. Okay, so we left 12.63 di atas. Okay, so this is, so happen dalam soalan tu, dia menjadi bentuk tu. So terbatal X tu sebenarnya. Kat bawah, you replace with the numbers. Again, this is a quadratic equation where you have to solve and eventually you will get the conversion of the CSTR as 0.9652. Sebab kan dia kata soalan ni tujuan dia adalah cari conversion kalau saya ada 5 dm cube CSTR dan syarat dia saya mesti produce 5 million gram per year of product C based on my limited operating time. So kita dapat tahu conversion dia sangat tinggi sebenarnya 0.9652. So what is the implication of this? It means that tak semestinya reaktor kamu kena beroperasi 24 hours 7 days per week. Within that, meaning kamu dah boleh plan your operating hours of your plant based on this calculation. Kamu tahu kalau kamu operate dalam condition ni pun kamu dah boleh capai conversion yang tinggi. So you don't have to operate your machine 24 jam, 7 hari seminggu, 365 hari. Because you know the longer operating time, you will incur more cost. So that's why sometimes this is important, engineering is important so that you can plan how your plant will operate within the requirement that you desires from your production. Okay, so that's for question A. So let me go to question B. Okay, so question B. Determine the volume of a plug flow reactor to achieve the same conversion as determined in part A above. So dia kata sekarang, katakanlah saya nak mencapai conversion yang sama. Okay, maksudnya untuk menghasilkan yang 5 million gram per year produk C, okay, untuk menghasilkan pada conversion yang sama, tapi saya nak tukar PFR. Katakan sekarang saya tak nak guna yang 5 dm cube CSTR, saya nak guna PFR, saya nak tahu berapa volume PFR pula yang saya perlukan. So that's the question. So meaning all the rest of information masih sama. Yang berbeza hanyalah kita nak kena cari volume untuk reaktor PFR yang baru ni. So again, you have to go back. You have to check the list of equation. Sekarang equation dia adalah untuk PFR, okay, liquid phase. Rate law masih sama. Minus RA equals to KCACB. So remember I told you, dia ada 3 syarat. Satu syarat berubah, equation dah berubah. Okay, so salah satu syarat berubah, equation pun akan berubah. So part ni kamu tengok, reaktor yang berbeza, naturally equation pun akan berbeza. So equation ni beri as volume PFR equals to FA0 per KCA0 square in bracket 1 per theta B minus 1 ln in bracket theta B minus X per theta B in bracket 1 minus X. So again, you are not expected to memorize lah because the equation is really long. Okay, but make sure you really know which equation to use. Okay, lepas tu kita solve lah. Okay, we have to replace one by one. Okay, first of all, kita nak cari volume, right? So belah kiri adalah benda yang kita nak cari. So belah kanan kita kena solve. So first of all, FA0. So jadi masalah, again, FA0 ni kita tak tahu. Okay, so kita tengok balik. Tapi dalam question A, kita dah tahu correlation dia. FA0 sama dengan 12.63 per X. Kita dah kira daripada part A tadi, kita tahu perkaitan dia. FA0 sama dengan 12.63 bahagi dengan X. Now, dalam part B, kita dah tahu conversion dia sebab dia kata conversion part B sama dengan part A. So, kita dah boleh replace the X with 0.9652. Okay, so you can now get your FA0 as 13.09. Okay, so again, this question is a bit confusing. So part A, kita tak tahu nilai X tu. So kita biarkan sahaja, kita ganti dalam equation. Part B, since kita dah tahu equation, kita dah tahu conversion itu, therefore we replace the conversion with the value, you can get straight away the FA0. Okay, so settle lah FA0 kita dah tahu. The rest kamu dah boleh cari. K kita dah tahu, CA0 we already know, theta B we already know, X also we already know. So again, all these things you substitute inside, you will be able to get the volume of the PFR as 0.5715 dm cube. So this question is not hard, but when you have time, please practice this equation. Equation ada ln, ada bahagi, ada bracket, ada sub bracket, ada main bracket. So if you do even one mistake in calculation, you may not be able to get the correct final answer. Okay, so hopefully you have time. You can do a little bit of practice for this. Okay, so done. So next question, we go part C. So part C, determine the conversion pula. Kalau above reaction conducted in a batch reactor with a reaction time of 0.1 hour. Okay, sekarang kita tukar batch reactor. Dia beritahu kita batch reactor tu the reaction time is 0.1 hour. Dia suruh kita cari conversion pula. So soalan ni macam kalau kamu tengok dia pergi balik benda sama. Kerja cari conversion, kerja cari reaction time, kerja cari volume, so on and so forth. Okay, sekarang dia suruh kita cari conversion, cari X. Kalau saya guna batch reactor. So again, kalau salah satu syarat berubah, equation already changes. So now I have to go back and find equation. Kalau dia adalah batch reactor, liquid phase with the rate law minus RA equals to KCA/CB. So the equation is given as reaction time equals to 1 per KCA0 in bracket 1 per theta B minus 1 ln bracket theta B minus X per theta B 1 minus X. So you may think dia macam sama dengan equation sebelum ni kan? Equation sebelum ni untuk cari volume PFR. Is somewhat similar tapi tak sama. Macam sama, yang sama ialah part belakang dia. Part depan ni kamu tengok kalau volume PFR, part depan dia FA0 per KCA0 square. Kalau reaction time, dia akan sama dengan yang part depan tu 1 per KCA0. So equation dia nampak macam sama tetapi tak sama. Okay, so similarly, you replace saja K, you replace CA0, you replace theta B, you know the reaction time is 0.1 hour. You can find the reaction time, which is, you can find conversion of the batch reactor, which is 0.9261. 0.9261. So that's the conversion if I conduct this in a batch reactor, right? Okay, so we are done with question number 2. I take 1 minute break for me to drink water. Then I will come back in 1 minute. Okay, saya tutup mic dengan phone, saya tutup mic dengan camera for 1 minute. I will come back to continue to the next question, right? Okay, right. So we come back to the next question. So we go to question number 3. Right. So question number 3. Now we go to gas phase reaction. So sebelum ni kita asyik buat liquid phase. Now we go to slightly harder. You go to gas phase reaction. So dia kata, the following gas phase reaction is carried out isothermally with no pressure drop. So importantly, dalam reaction ni sekarang kita dah guna gas phase reaction. So kamu ingatkan saya kata phase, liquid phase, gas phase will produce different equation for you. So you have to really understand apa perbezaan dia bila kita guna liquid phase atau kita guna gas phase. Okay. So reaction dia, A to react to produce 1B and 2C. Okay, so dia kata The activation energy of the reaction is 15 kilojoule per mole with a pre-exponential factor of 0.485. Okay, so maksudnya EA 15 kilojoule per mole, A 0.485. Okay, so that's the information that give us. Kita tahu EA, kita tahu A. They say the initial concentration of pure A is 5 mole per liter. So Ca naught 5 and 40% of A was converted. X is 0.4. So X 0.4, Ca naught is 5. Okay, and then dia kata the reaction is second order with respect to A. So soalan ni kata sekarang dia beri kita information pasal reaction order dia. Sebab this is non-elementary. Kalau kamu perasan, reaction dia 1A. Tapi dia punya reaction order sekarang adalah second order with respect to A. Means this is non-elementary rate law. So they give you the information. So from this information, we can deduce rate law dia mestilah minus RA equals to KCA power of 2. Sebab second order with respect to A. Okay, so next one. Okay, let's go to the question. Determine the reaction temperature in Kelvin when the above reaction is conducted in a batch reactor with a reaction time of 15 minutes. So question ni kata, they ask us to find T, temperature, reaction temperature, and kalau this reaction kita conduct dalam batch reactor, and this is batch reactor tu masa tindak balas dia 15 minit. So this is very interesting, right? Kita nak cari temperature. Beritahu dalam batch reactor, dan batch reactor tu ada masa tindak balas dia hanyalah 15 minit. So of course, if you are not sure where to go with this, you come back kepada design equation dulu. Sebab beritahu kita batch reactor 15 minit kan? So you know from the equation, kalau saya ada batch reactor, gas phase dengan rate law minus RA equals to KCA power of 2 sebab second order with respect to A. The equation is given as reaction time dalam batch reactor equals to 1 per KCA naught in bracket X per 1 minus X. So this is the equation given to us. Okay, so you may ask, tapi kita nak cari temperature. Dalam equation ni tak ada pun temperature kan, tetapi kamu dah tahu fundamentally, okay, temperature will affect the value of K. Maksudnya, kalau daripada equation ni, I can find first K, and saya tahu K is correlated by the Arrhenius equation. Sebab Arrhenius equation akan beri correlation ataupun perhubungan di antara K dengan temperature. Meaning, from the batch reactor punya equation, I find first K, and the K I will replace into the Arrhenius equation for me to get the temperature. So this is a question where it's different in the sense that kamu kena faham sendiri what information is given to you and how you correlate untuk mencari apa yang disuruh. So dalam soalan ni dia tak suruh kamu cari K pun. Okay, tapi kamu tahu kalau saya nak dapat temperature, saya kena tahu nilai K. Nak tahu nilai K, saya kena dapat cari daripada equation yang sebelumnya. So that's the challenge. Okay. So from this reaction equation, okay, first of all we find K. So means the rest tu kena ada nilai lah kan. Okay, so first reaction time given 15 minutes. K kita nak cari, Ca naught kita tahu initial concentration Ca naught 5. Conversion dia 0.4 from the question. So I can replace everything. I will get the value of K as 0.0089 from the equation. Kita solve, kita dapat K. Maksudnya K ini adalah 0.0089. Tapi belum habis lagi kan? Sebab kita nak cari temperature. So we learn that temperature and K is correlated through Arrhenius equation where they says K equals to A exponential bracket minus EA per RT. So from this, okay, I can find my temperature. Okay, so my value of K, which I already calculated just now as 0.0089. Okay, A is the pre-exponential factor, which is 0.485, which given from the question. Nilai K ni daripada soalan, 0.485 tu adalah nilai A kamu. exponential negative EA per RT. EA is given as 15 kilojoule per mole. So you must convert into joule per mole. So you times with 1000. So 15 kilojoule per mole is 15,000 joule per mole. Divide by R value of 8.3144 joule per mole Kelvin, and T is what we want to find. So again, satu equation, satu saja unknown, yang lain kita dah tahu nilai dia. Therefore, you can find the value of temperature, which is 451.24. So this is example of question where you are not given directly the solution, or you will have to plan by yourself what that you have to find. So kamu kan tahulah nilai ni diberi, saya boleh guna untuk cari apa. Daripada nilai ni baru saya bercari yang seterusnya. So that's why you need to plan yourself the solution for this kind of question. Okay, so I go to the second one. So the second one, panjang sikit. Determine the volume of a PFR if the reaction is conducted at the same temperature as in part A above with initial rate of 10 liter per minute. Okay, so soalan ni kata sekarang, cari pula volume PFR kalau saya conduct reaction yang sama pada suhu yang sama. Maksudnya apa? Kalau dikata suruh conduct pada suhu yang sama, maksudnya nilai K yang tadi kamu kira pada part A boleh digunakan dalam part B. Suhu sama, nilai K tu sama. So kamu tak payah cari nilai K yang baru. You can still use the K that you have found in part A, and they give us additional 10 liter per minute, which is your epsilon naught. Sebab dia kata initial rate. So kamu kena ingat, kalau gas phase, volumetric flow rate epsilon and epsilon naught is not equal. Outlet volumetric flow rate tak sama dengan initial volumetric flow rate. So dalam kes ni, yes Mimi, is there any question? Hi Mimi. Yes, yes.
Yang EA dia tu, nilai untuk EA tu,
Aha.
500 ke 15,000?
Sorry, nilai EA ke nilai R? Enggak?
EA.
EA yang ni? Aha. Okay. Kenapa ya?
Dia punya nilai tu
Aha.
8500.
8500? Mana 8500 eh?
Sorry.
Mana satu? Tak apa Mimi. Maksud Mimi apa?
Sorry, salah tengok.
Salah. Okay. Alright. Okay. So, saya takut kalau soalan saya tak sama, kamu beritahu saya. Kerana saya tukar jawapan. Saya takut soalan saya tak update. Okay. Dalam ni, EA dia 15 kilojoule per mole. Okay. Sebab saya tukar 15,000. Don't forget equation dia ada negatif EA per RT. Sebab tu ada nilai negatif kat depan. Okay. Right. Mimi dah clear ke? Mimi dah okay ke? Okay. Alright. Thank you. Okay. So, come back to this question. Alright. So, kalau K temperature sama, therefore the value of K is the same for part B. Okay. Tetapi sekarang kita nak cari volume PFR. So, again, you go to your notes, you check. Kalau dia adalah gas phase, PFR dengan rate law dia minus RA equals to KCA power of 2. Sebab soalan kata reaction is second order with respect to A. You find the equation that fulfill all these three. Equation dia equation yang paling panjang daripada semua yang kamu belajar, which is this equation in rate. Volume PFR sama dengan FA0 per K CA0 square. Yang belakang yang panjang itulah. Okay. Again, this question is provided to you. Kamu tak payah bimbang. Right. Okay. Again, untuk menyelesaikan soalan ni, dia equation tu ada version 1, version kedua. Version yang diberi kepada kamu adalah version di mana dia ada FA0, dia ada CA0. Ni kalau kamu tahu FA0, kamu tahu CA0, kamu guna version ni. Ataupun dalam kes kita sebenarnya tak tahu FA0. Kita tahu epsilon naught 10 liter per minute dan kita tahu CA0 5 mole per liter. So you have option. Katakanlah kamu nak guna version pertama ni, kamu kena cari dulu FA0. Baru kamu boleh guna version pertama ni. Sebab saya ada CA0, saya ada epsilon naught, saya boleh cari FA0, saya boleh guna equation yang merah ni. Ataupun if you want a faster one, you may use the second version because Same concept. When I have one FA0 at the top, I have one CA0 at the bottom. When I divide them, I get epsilon naught. So sekarang kat atas epsilon naught, kat bawah tinggal K, tinggal satu lagi CA0 yang tak dibahagi. The back part is still the same. So either one you can use, but you have to understand kalau yang merah ni kena satu step tambahan, kalau yang hitam ni tak payah satu step tambahan, terus ganti. Okay, so now to replace is easy, but you have to understand pula macam nak cari epsilon. So kamu pernah belajar dalam chapter 3, tapi kita tak praktis sangat. Now kita praktis. How to find epsilon? Epsilon, sorry, no epsilon, epsilon. So to find epsilon, if you remember, the formula is given as YA0 sigma. Equation ni diberi. Epsilon sama dengan YA0 sigma tu, equation tu diberi. Okay. YA0 tu apa? YA0 tu kan adalah initial mole fraction of A. So kalau kamu tengok soalan, dia kata initial concentration of pure A. Maksudnya yang masuk asal adalah 100% A. So YA0 kamu adalah 1. So okey lah, YA0 kamu senang. Pure A, YA0 1. Sigma. So kalau kamu ingat, sigma equation is not provided to you. Sigma tu satu lagi equation. Equation untuk sigma ni tak diberi kerana equation ni tak fix. Remember I told you, sigma adalah sebenarnya mencari the ratio of the stoichiometric coefficient. Tetapi ratio ni ada positif atau negatif bergantung kepada adakah dia reactant atau dia product. So it will be positive stoichiometric coefficient ratio for product and negative for the stoichiometric coefficient ratio of reactant. In our reaction is 1A produce 1B and 2C. So this part yang kamu kena berhati-hati. Kadang-kadang we might make the mistake because we don't realize the stoichiometric coefficient sekarang dah lain. 1A, 1B, 2C. And B dan C adalah product. That's why equation dia become C per A plus B per A because C and B is product minus 1. So technically is A per A. Tapi A per A itu satu. Sebab tu dia tulis minus 1. Okay, so C per A is 2 over 1. B per A is 1 over 1 minus 1 lah. Okay, so you will get your epsilon as 2. So get epsilon ni dia boleh jadi positif, dia boleh jadi negatif. Okay, bergantung kepada your reaction actually. Okay, so if you get negative pun also fine, you get positive is also fine. Okay, so in our case here we get epsilon as 2. So this part kamu kena tahulah pengiraan dia. Equation tu diberi tapi sigma tu tak diberi sebab sigma tu berubah depending on the question. Okay, so the rest you can already replace the same. I know the value K, I know CA0, you already know epsilon naught, you know epsilon. You can calculate but you can see pengiraan dia panjang kan. So that's why I ask you later on when you got time, you have to practice yourself sebab equation ni panjang. And kamu tengok ada darab, ada tambah, ada bracket, ada sub bracket, ada kuasa 2, ada negatif, ada positif. So that is the challenge. Okay, but if you calculate correctly, you will get the volume as 330 liter. Okay, so that's for question number 3, part B. So it's not hard actually, tapi dia ada a bit tricky lah. Setempat straightforward, setempat dia tricky sikit. Okay, right. So we go to the next question. I think we only have time for one question. Let me think question mana yang saya nak solve. Question 5 is pressure drop. This one is question 4 is no pressure drop. Okay. So I will do question number 5 first about the pressure drop. If we have time, I will go to question number 4. But if we don't have time, okay, please try to do this by yourself. Actually, it would be good if you can do question number 4 by yourself. But let's see, kalau saya sempat, saya cover. Tapi saya nak cover question number 5 dulu. Sebab question 5 ni ada pressure drop. Okay, so I go to question number 5 first. The following is the gas phase decomposition of pure dilute butyl peroxide to produce ethane and acetone. Sekarang kita dah guna compound yang sebenar. So kalau kamu get confused menggunakan compound yang sebenar, you can convert straight away to A, B and C. So reaction ni sebenarnya 1A produce, 1B dan 2C. Kan? Sebab 2 di hadapan ni, so 2C, 1B, 1A. The reaction is carried out isothermally in flow reactor. Tindak balas ni isothermal, tak ada perubahan suhu. The pressure is 6 atm initially, but there is a pressure drop of 2 atm during the reaction. So apa maksud dia? Maksudnya pada kejap saya something is not right here. Okay, sorry. So first of all, okay, sebelum saya lupa, ada satu information yang saya terskip. Information yang pertama ni, dia kata decomposition of pure diethyl butyl peroxide. Maksudnya composition of your reactant A, dan dia kata pure. Maksudnya YA0 kamu adalah 1. Maksudnya awal tu semua 100% mol persen adalah A kamu, which is your pure diethyl butyl peroxide. So YA0 kamu 1. Next information, dia kata initially pressure kamu 6 atm. So ya, kamu punya P0 6 atm. Pressure asal 6 atm. Tetapi there's a drop of 2 atm during the reaction. Maksudnya dalam tindak balas, semasa tindak balas kamu, pressure kamu jatuh sebanyak 2 atm. So your P0 is 6 atm. Your P will be 6 minus 2, which is 4 atm. Sebab dia kata pressure drop of 2 atm, ataupun dalam bahasa Melayu, kejatuhan tekanan sebanyak 2 atm. So berapa pressure kamu selepas tindak balas will be 6 minus 2, 4 atm. So sekarang this is something new. Sebelum ni kamu solve soalan tak ada pressure drop. Soalan ni sekarang ada pressure drop. Okay, so sekarang P0 6, P adalah 4 atm. Okay, so next dia kata reaction is second order with respect to diethyl butyl peroxide, your A. So you can write down the rate law. So rate law dia sekarang menjadi minus RA equals to KCA power of 2. Sebab reaction dia second order with respect to your A. Then next dia kata the feed rate of diethyl butyl peroxide is given as 379 million gram yearly. So sekarang interestingly, dia beri kita feed rate. Okay, so dia beri kita sekarang tadi kalau question yang sebelumnya dia bagi production rate. Berapa produk yang saya nak hasilkan. Dan soalan ni dia beritahu kita feed rate. Okay, dia beritahu feed rate kita setiap tahun kita akan menggunakan sebanyak 379 million gram. Maksudnya feed rate ni adalah apa? Kita punya A. Berapa A yang saya akan gunakan setiap tahun adalah 379. Okay, so maksudnya your diethyl butyl peroxide itu adalah kamu punya A kan? Okay, so dia adalah sekarang mass flow rate juga sebab gram per year is mass flow rate. So dia adalah soalan seterusnya, dia MA ke MA0? Mass flow rate M, right? Okay, adakah dia MA atau MA0? So kamu kena ingat, dia kata feed rate. Berapa asal suapan yang saya gunakan A saya? So maksudnya yang diberi 379 million gram tu adalah kamu punya MA0. Okay, so again I repeat, soalan sebelumnya dia beri kita production rate of product C. So jadi MC. Kenapa bukan MC0? Sebab dia kata itu yang telah dihasilkan atau kita nak hasilkan. Dalam soalan ni dia kata berapa yang kita akan suap atau berapa yang kita akan gunakan bahan mentah kita, which is our E. So how much our feed is MA0. So MA0 kita is 379 million gram yearly. So by now you can guess kan, kalau saya ada MA0, saya ada molecular weight, saya boleh tukarkan daripada MA0 kepada FA0. So tadi daripada FC, kamu kena daripada MC, kamu tukar FC, kamu cari FA0. This one is quite straightforward. Daripada MA0, cari FA0. You can find, okay. Later on we will do that, right? Okay, then dia kata with initial concentration 5 mole per liter. So dia beri kita CA0 is also 5 mole per liter. So dia beri kita MA0, dia beri kita juga CA0. Right, okay, so dia kata determine the volume of a single PFR and a single CSTR to achieve 95% conversion. So dia kata kita nak cari volume CSTR, volume PFR, conversion mesti 0.95. Dan dia beri kita juga additional information. Reaction rate constant at reaction temperature, your K 0.4, Dia beri kita molecular weight, naturally lah. Kan tadi saya kata kalau kita ada MA0, kita boleh tukar kepada FA0 provided kita tahu molecular weight dia. That's why they give us the molecular weight as well as dia beri kita juga plant tu punya limitation. Setiap setahun dia hanya bekerja 360 days dan setiap hari hanya 8 jam sahaja plant tu beroperasi. So sekarang in the nutshell the question says now, with this limitation of time and saya nak capai conversion 95% and bahan mentah yang saya nak gunakan mesti 379 million gram every year, how big my reactor shall be? Itu je sebenarnya soalan dia. Okay, so we have to calculate one by one again lah. Right, so again, part soalan ni yang susah adalah sekarang, dia dah ada pressure drop. So kamu kena check dalam list equation, okay, untuk equation yang diberi dalam test atau exam, okay, saya tak beri dalam bentuk pressure drop ni. So kamu kena ingat sendiri bagaimana equation original ni akan bertukar kalau saya beri pressure drop. So apa yang bertukar sebenarnya, you only have to add in the equation yang P0 per P power of 2 ini. So, kamu kena ingat lah, kamu kena check with notes. Untuk setiap syarat tu, kalau ada pressure drop, apa yang akan berubah kepada equation dia. So you have to remember somewhat how the equation changes if I have pressure drop. So sebenarnya yang berubah adalah hanya kita akan tambah P0 per P kuasa 2 sebab sekarang ada pressure drop. The rest kalau kamu tengok masih sama macam equation yang kita solve sebelum ni. Yang PFR tadi question panjang-panjang kita dah pernah solve, right? Just that sekarang sebab ada pressure drop, dia akan tambah part yang P0 per P power of 2. So first of all, again, we have to substitute each one with the correct numbers. So first of all, volume we want to find. So first of all, kita kena cari FA0. So again, if I have mass flow rate of A, MA0, I want to change to FA0, I will just divide with the molecular weight. So next question, mass flow rate saya adalah dalam bentuk gram per year. Molar flow rate saya dalam unit apa? Of course, mole per what unit for my time. So again, you just check from the question, any other numbers yang ada unit time. Kamu ikut je unit tu. So, contoh dalam soalan ni, unit dalam K kamu, unit time dia adalah minute. So means I will change from gram per year kepada mole per minute. Okay, so let's say kata, tapi kalau saya nak guna hour ke second, boleh. Tetapi kamu kena pula convert unit time dalam K ni. So either way, either you decide, katakanlah kamu decide saya nak guna hour sebagai unit time kamu. Boleh, tetapi you must remember unit minute dalam K ni kamu kena convert juga kepada hour. Either you do that in your FA0 or you do this in the value of K. Tapi unit dia kena constant. Sebab tu saya kata cara paling senang, tengok unit daripada nilai lain, unit time dia ikut unit time tu kamu dah senang. Okay, so I will change from gram per year kepada mole per minute. So first of all, naturally, I will divide with the molecular weight to convert from gram to mole. So you can see here, I can cancel my gram and gram. I'm left with mole per year. However, the question says for every 1 year, I only operate 360 days. So sekarang saya akan cancel year per year. Saya tinggal mole per day. Tapi saya nak apa? Mole per minute kan? So every day, I only operate 8 hours. Cancel day, tinggal hour. So sekarang tinggal mole per hour. So naturally 1 hour 60 minit lah kan. Okay, so you can now get your FA0 as 15 mole per minute. So kita convert daripada MA0 kepada FA0. Soalan yang sebelum ni daripada MC kepada FC dan kepada FA0. So soalan tu lebih susah sikit lah. Soalan ni straightforward. MA0 tukar kepada FA0. Okay, so then you get FA0, dah settle part FA0. Okay, K dah diberi 0.4. CA0 is also given as 5. Then next one, P0 is 6. P is 4 sebab dia ada pressure drop of 2 atm. So 6, 4. Okay, katakanlah soalan tu kata ada pressure drop 2 atm. So maksudnya kalau ada kejatuhan tekanan kepada 2 atm, maksudnya P kamu adalah 2 atm. So you must see the difference between the word 2 to and off. If there's a pressure drop off 2 atm, maksudnya kejatuhan tekanan sebanyak 2 atm. If I say there's a pressure drop to 2 atm, maksudnya kejatuhan tekanan kepada 2 atm. Means your P is 2 atm. So you have to be careful of the word off and the word to. It give you a significant difference in your numbers. Okay, so done. The next one is epsilon. So cari balik epsilon. So again, epsilon is bukan epsilon, volumetric flow rate. Epsilon is epsilon lah. Okay, epsilon sama dengan YA0 sigma. So YA0 pure A 1. Epsilon, sigma again positive for product, negative for reactant. Our reaction is 1A, 1B, 2C. So that's why it become B per A plus C per A. Ingat sebab dalam kes ni B dan C adalah produk. Sebab tu tambah. Minus 1, technically A per A. So you get your epsilon as 2. Okay, so now you can replace in the big equation. You will get the reactor volume as 468.62 liter. Okay, so baru cari conversion dalam PFR. Sekarang cari conversion dalam CSTR. So nilai semua boleh digunakan. Nilai yang sama. Just that equation sahaja yang dah berbeza. Sebab equation sekarang nak cari untuk CSTR. So kamu tengok balik notes. Kalau CSTR, kalau sekarang ada pressure drop, apakah equation tu? Again, saya tak provide equation yang ada pressure drop. Kamu kena tengok, kamu kena ingat macam mana pressure drop punya part tu akan ditambah dalam equation kalau ada pressure drop. Okay, so the equation will become like this. So subsequently kamu replace saja dengan nilai. Dia hanya nilai lain masih sama. Yang berbeza hanya equation sahaja sebab kita tukar reactor. Okay, subsequently you will get the volume as 10,785.83. So now you have completed lah conversion dalam PFR dan conversion dalam CSTR. Okay, right. So since we have a little bit of time, I will just go roughly for question number 4. Okay, question number 4. Okay, right. So question ni tak susah, tetapi apa cabaran dia? Okay, cabaran pertama, kalau kamu tengok, soalan A ni dia beri kamu space velocity, disuruh kamu cari CA0. So I would like you to try. Sebab kalau some soalan, kalau kamu tak try, then you will not know whether you can do or not. Soalan ni cabaran dia, sebelum ni saya hanya sentuh volume, conversion. Tapi soalan ni dia beri kita guna space time. So kamu kena faham bagaimana equation yang bentuk merah ni akan berubah kalau saya nak cari space time. Space velocity. Lagi berubah space velocity. Dalam note saya ada bagi version untuk mencari dalam bentuk space time. Tapi soalan lebih mencabar, saya suruh cari dalam bentuk space velocity. Tapi kamu ingat kan, kalau space time, space velocity sama dengan 1 per space time saja sebenarnya. So you should be able to solve this by yourself. Ada space velocity, disuruh kamu cari initial concentration of A. Itu part A. Dan part B, dia tukar sikit. Disuruh kamu pula cari mole fraction baru. Kalau saya tukar mole fraction dia, bila saya tukar situation, saya nak kamu cari mole fraction yang baru. Okay, so I will not discuss in detail because I would like you to try this question by yourself. If you are able to do this by yourself, then you should be okay for reaction chapter 4 lah, right? Okay, so that's all for our class for today. I will see you later in 1 hour time for our lecture. Just a residual lecture for chapter 4. Then we are done for today finally. Okay, so thank you very much. I will see you in 1 hour time. I think everybody come for the tutorial except for one. Okay, all right. So that's all for today. Thank you everyone. See you in 1 hour time.